So today we're going to be solving exponential equations. Now, an exponential equation is something that looks like this. You have something on the left side is equal to something on the right side, and both of the equations usually end up having the same base. Now, if the bases are not the same, then you can't do something like this. If I have something symmetrical, I could do this, but if that doesn't happen, we have some steps we have to follow. Now, one of the things that I want to emphasize is that when we have our same base, you'll hear me use the term drop the base. Now, that only happens when we have both bases on either side of our equation. And just like before, we have a few unique things that we're using for our bases. Now let's take a look at our problems here. Suppose I have bases that aren't the same. Now in this case, we have 2 to the x is equal to 64. Now, just like yesterday, or last lesson, we used bases of 2, 3, 5, 7, and 10 for most bases. And that's what's going to end up being used in this unit. Now, we're going to go through a series of steps, then we're going to do these problems. Now, let's begin. So, you remember change of base from the worksheet yesterday or today. Basically, we used change of base, and we basically made sure that the equations or numbers had exactly the same base. We're going to do the same for our next problem. So we're using change of base to write both sides with the same base. Now, once you've used power of a power or anything to equate the sides, then we just simply set the exponents equal. And then we go and solve the equation. So let's go and do that. Now our current problem has 2 to the x is 64. The big hint here is 2 to the x. Remember, that's one of our regular bases that we're using to replace this number on the right side. We're going to try and make it match to this. So now we're going to write 2 to the x is equal to, well, 2 to the 6. Because 2 to the 6 is equal to 64. Now, so that was part 1. We're done part 1. Now that we have the bases equal and nothing is impeding our progress, we can now drop the base, i.e. x is equal to 6, and there is our final answer. Let's go on to some more difficult problems. Most of your problems that you're going to start off with in this section will look like this, but we'll get into some more difficult problems next. Suppose I have 3x minus 1 equals 27. The big hint here is we have 3. So we're going to use 3 as our base. So we got 3 to the x minus 1 on this side is, well, 27 is 3 to the 3. Now that the left and right side of our equation have exactly the same base and there's nothing left to do, all we're going to do is drop the base. And so now we have the equation x minus 1 is equal to 3. So now we need to move this minus 1 to this side. Moving it to the other side, we end up with 3 plus 1 is equal to x. Simplifying the right side, we end up with x is equal to 4, and that is our solution. The next problem we have is very similar. We'll do it again. So we have 5 to the 2x minus 1. 625 is 5 to the 4, so you can check that and you're good to go. And now, since we have that, our bases are the same on both sides, we drop the base. So we got 2x minus 1 is equal to 4. Now, we're going to move our minus 1 to the other side, and so we have, well, we have 2x is equal to 4 plus 1, which is equal to 5. So 2x is equal to 5. So now we must get rid of the x, so we divide both sides by 2. And most times in your notes on your homework you would get 5 over 2. But sometimes I'll ask you for the decimal, or you could write 2.5 as your answer. Both are valid. Now your homework for this part is day 2, and it's worksheet number 2. Good luck. Now I didn't get to teach this in class yesterday, but recall, we had stuff like this on our first day of changing the base. So suppose I had 8 cubed times 2 to the 4. We'd use 2 as our base, and we'd get 2 cubed raised to the 4 times 2 to the 4, and we'd simplify and make sure that the 2 cubed and the 4 turns into 2 to the 12 times 2 to the 4, and we'd use our basic rules. So we get now 2 to the 16, which is some ridiculous number. Now imagine I give you an equation where both sides of our equation don't have a nice base. Remember, our base numbers are 2, 3, 5, 7, and 10. Looking at this equation here, the base equation, the base exponent that we're going to use for these two numbers, 8 and 32, is going to be 2. So let's go and replace them. So we're going to have bracket 2 cubed raised to the x is equal to, well, 32 is the same as 2 to the 5. And now we must do power of a power on this bracketed expression here. So we end up with 2 to the 3x is equal to 2 to the 5. So now that our base is the same, we go back to what we were doing before. We drop the base, and now we solve for x by dividing both sides for 3, and we end up with x is equal to 5 over 3, or 1.7. Now, for the next problem we have here, we have 625 is equal to 125. Our big hint is the number 5 at the end, so we're going to use 5 as our base. So now we're going to have 5 to the 4 replacing 625, all raised to the x, and 125 is just 5 cubed. So now we're going to assume we're going to use power of a power, so we need to multiply these two to get 5 to the 4x is equal to 5 cubed. So now that we're here, we just drop the base to get 4x is equal to 3. Now we divide both sides by 4 to get rid of the 4, and we end up with x is equal to 3 over 4, otherwise known as 0.75. And the types of questions for this are on your sheet, and you're going to do number 3, like that. Good luck. Moving on to question type 4. We have some more difficult problems. So let's go through them. I'm just going to go through them and show you. So for this problem here, 4 and 28, the number that we can replace, both 4 and 28, the base is going to have a 2 in it. So let's do that. And so now we get 2 squared raised to the power of 2x minus 3, and 128 is just 2 to the 7. So now, because this is power of a power, we have to apply the 2 to the 2x and the 2 to the minus 3 to get 2 to the 4x minus 6 is equal to 2 to the 7. And now we're back to dropping the base. 4x minus 6 is equal to 7. Now we're going to move our 6 to the other side. So now we're going to get 4x is equal to 7 plus 6, which is 13. So 4x is 13. We divide both sides by 4. And we can leave our answer as x is equal to 13 over 4. Otherwise known as 3.25. Now we'll do these last two problems exactly the same. Now you'll notice on the left side we replace 36 with 6 squared. We make sure that's in a bracket. It's all raised to the x minus 1, and 216 is the same as 6 cubed. And for the left side it ends up being 6 cubed to the x. Now the difference between this problem and the previous problem is that we have to basically do our distribution, our power of a power on both sides of the equation. So now we end up with 6 squared raised to the x minus 1 is going to be, well, the 2 hits the x and the 2 hits the minus 1. So now we end up with 6 to the 2x minus 2 is equal to, now the 3 and the x are hit against each other because it's power of a power. So now we end up with 6 to the 3x. And now what we have to do for this is we just simplify by dropping the base. So we get 2x minus 2 is equal to 3x. And now we have to put all our x's on one side. We have to isolate. In this case, all my x's are always put on my left side. So I'm going to move my x here over to the front, and 3x becomes minus 3x plus 2x minus 2 equals 0. And notice I have a minus 2 on the wrong side, so I'm going to move that over here. So now we're going to get, well, 0 plus 2 is negative 3x plus 2x, and we end up with negative x on the right side equals 2. And in order to get rid of that minus sign, we divide both sides by negative 1, and we end up with x equaling negative 2. This last problem, I'm just going to go through it really quickly. It shouldn't be too difficult. All you need to realize is that our base for these two is going to be 3. And we have for the right side, 243 is 3 to the 5 raised to the 2x plus 1. And now we need to add, we now apply power of a power to both sides of these equations. So this and this hits this, and we end up with this problem. And now that we have this solution, we're going to drop the base because both of the bases are the same. And we move all our x's to one side and all our numbers to the other, and then combine like terms. We get something like this. Then we end up with x equal negative 11 over 7 as our final answer. Now your work for today, I want you to try working on number 3 in our set. You should also be able to do number 4 based on these questions here.